So in this video, I'll be solving UNILAS semester 2, tutorial sheet 1, chemistry, which is on thermodynamics, okay? So my main focus is on question number 7, which is saying when 1 mole of nitroglycerin decomposes, it produces a violet explosion, okay? And releases 5.72 times 10 to the power 3 kilojoule of heat, okay? Then that's the chemical equation there of this nitroglycerin decomposing. Okay, so we have this as a reactant. Okay, it decomposes, then these are the products it's giving you. Okay, so now they are saying, is the reaction exothermic or endothermic? Okay, so the first question is asking us to determine whether the reaction is exothermic or endothermic. Okay, then we'll draw the enthalpy diagram for this same reaction. Okay, so now for us to know whether the reaction is exothermic or endothermic, the key word here is releasing. Okay, so when in a chemical reaction, when energy is released to the environment, it means that that reaction is an exothermic reaction, okay? If heat is being gained from the environment, meaning that reaction is an endothermic reaction. So we can see here that in this reaction, uh, uh, heat was being released to the environment, okay? And that's the amount of heat which was being released there, okay? So we can conclude that our reaction is an exothermic reaction, okay? So now, how do we come up with a energy diagram for this type of reaction, okay? So I'll draw an energy diagram for an exothermic reaction for this question. Then I also show the the enthalpy diagram for an endothermic reaction. Okay, so let me start with the enthalpy diagram of this question, our question, which is an exothermic reaction. Okay, so you draw your y-axis like that. Okay, then the x-axis like that. Okay, so here in the y-axis you can indicate energy, or you can say enthalpy, change in enthalpy. Okay, so let me just say change in enthalpy here. Okay, so you're having your change in enthalpy. Okay, like that. Then here I can say reaction progress. Okay, so this is how the reaction is progressing. Okay, so reaction progress, if you want, you can put time here. Okay, so what I'm going to do, so So in an exothermic reaction, reactants are going to are going to be at higher energy level compared to the products, okay? So what you are going to have is something like this, okay? So you are going to have your reactants there, okay? So the reactants are going to be here. Then you have this mountain like okay, so you have something like this. Okay, I'll explain about this mountain. Okay, then you are going to have your products down there at a lower energy. Okay, so at a very low energy. Okay, so in an exothermic reaction, you find that reactants, okay, are going to be more favored than the products, okay? So you're going to have your reactants having higher energy. Since heat is being released, you're going to find that reactants are going to have are going to be at a higher energy level compared to the products, okay? So you find that your products are going to be down there, okay? So the products are going to be down there, okay? Products there, okay? So you have products there, okay? So meaning the action is progressing from the reactant to the products. You have a downward change in what? In enthalpy there, okay? So you have a change in enthalpy there, okay? So now there's this energy here. So there's this energy difference which you need to overcome for you to have your product. Okay, so this energy difference is called activation energy. Okay, so the energy difference from here to where the formation of products are. So from here, from there, from that top to where that reactants are, that's the energy difference. We call it activation energy. Okay, so that is the amount of energy you need to overcome for you to get your products. Okay, so it's called activation energy. Okay, so EA, most of the time it's donated as EA. So you have your activation energy there like that. Okay, so this is the enthalpy diagram for this question. Okay, so you can also add something. Okay, so if you talk about this activation energy, let's say you introduce something like an enzyme, a catalyst like an enzyme. So what a catalyst is going to do is going to lower this mountain you're supposed to climb for you to produce your product. So it's going, what a catalyst is going to do is going to lower your activation energy. Then you have activation energy, something like that there. Okay, so that's what you're having for an enthalpy diagram for an exothermic reaction. Okay, so for an endothermic reaction, so this is the answer to our question in short. Okay, this is the answer. The energy diagram is this one. Then the reaction is exothermic. Okay, so now for an endothermic reaction, in terms of how the energy diagram, just in case you are asked how the energy diagram for an endothermic reaction is going to look like. Okay, so you draw the same thing. So you have the y-axis there, the x-axis there. Okay, so what you are going to have, unlike here, you are going to have your reactants are going to be down there. So you have reactants down there. Okay, then you have this mountain there. Okay, then your products are going to be on top. Okay, so your products are going to be at higher energy level compared to your reactants. Okay, so you find that here you have your products. Okay, so you have your products there. Okay, then your reactants are going to be down here. So you have your reactants there. Okay, so those are the are your reactants down there. Okay, then in terms of reaction progress, okay, so your reaction is going, your reaction progress is going to be like this. Okay, so that's your reaction progress. Okay, so that's how your reaction will be progressing. Okay, then if you are to ask, if you are asked to uh to 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 know the what the energy difference. Okay, so the energy difference, okay, so this is your reaction progress. Okay, so the action or the change in enthalpy is going to look like this. Okay, from here for you to produce your products here. So this is your change in enthalpy. Okay, this is your change in enthalpy. Okay, then the activation energy is the energy you need to overcome. This energy you need to overcome for you to have your products there. Okay, so this energy is going to be this one here. So this amount of energy you need to overcome this amount of energy for you to have your products. Okay, so this is your activation energy. Okay, so you are still having your reaction progress here. Okay, reaction progress, you can write time if you want. Okay, then you have your what your energy there. Okay, or change in enthalpy. Okay, so that's what you are having. So these are the two diagrams you can have for an endo. So this one down there is for an endothermic reaction where you're having reactants down, then products on top. Okay, then this other diagram, this one here, is for an exothermic reaction where you're having reactants on top, then products down. Okay, this one, the reaction progress, you show the arrow downward. Okay, then the other one for reaction progress, you follow the arrow up like that. Okay.